that suppose that this is the motor for the anchor, for the windlass. The customer complained that the anchor is going down, but not up. The anchor is going down, but in the other position, nothing. Okay, you need verify. The first step is go where the motor is located and verify if the motor is in good condition. Doesn't matter if the solenoid control box or the switch is good, you need verify if the motor is in good condition. Directly into the right side and left side movement. Okay, this position is good, and now, okay, my motor is in good condition. With this, with the touch probe, if my switch is good. Okay, I have power in the input. Yes, I have power in the input. Oh, I need verify down this position. Okay, good. I need verify the second one. Nothing. No power here. My switch is damaged. I need to replace the switch, the solenoid control box. You replace that expensive equipment with $20 for this situation, and this is a permanent good solution. You can replace this for this forever. You don't have any problem, you don't have any inconvenience. The only that you need verify is the capacity in amps of the relays. Oh, what is the capacity of the motor? Okay, depending on the capacity of the motor in amps, you need to replace the capacity of the relays, and you do the installation. In this particular case, I put both of them. I connect the switch selector. I have one output for one and the output number 2 for the other situation. This is the thing. What is the procedure to change rotation in AC motors? The procedure to change the rotation of AC motors is with contactors. Contactors are basically breakers remote activated. Breakers remote activated. Exactly the same like the relays in DC. You remember the relays in DC? Those are the relays. This is the position A and position B, the big current that I need pass from this point to this point. But this contactor in between this and this is normally open. Only when I bring the signal, the remote signal from the ignition switch in the fly bridge or in the pilot helm, the contact in between this and this close and the current pass to the other side. This is a remote activated switch. I have the main breaker on the AC panel of your boat. The main breaker, phase 1, phase 2, phase 3, phase 1, phase 2, phase 3, and that power is coming from the source of the power, the generator, the inverter, or the short power. Okay, the main breaker send the power to the contactors. The contactor number 1 receive the phases in this order: black, red, and purple. That's the input of the first contactor. We are going to install this contactor for clockwise rotation. The contactor is basically a breaker, the 3-phase breakers, with a couple of inputs for the signal. The signal should be AC or DC. For example, this is not properly a contactor, but it's exactly the same. It's a breaker, a 3-phase breaker, with the 2 inputs on the side for the signal. What is the function of the signal? Open and close the breaker. Open and close the breaker. Where is coming that signal? It's a remote signal. That signal, once again, is coming from the fly bridge, from the pilot helm, and that signal could be DC signal or AC signal, low current signal. Contactors. I have 2 contactors here, 3 inputs, 3 outputs, 3 inputs, 3 outputs. Okay, the first contactor is for clockwise rotation, and the second contactor probably for counterclock. Okay, the first contactor have 3 inputs: black, red, and blue. The black one, the first position of the first contactor is connected with the first position of the second contactor. 0.3, 0.4, 0.5, 0.7, 8, and we are going to reach the maximum is 0.9. Is 0.9. In this way, the galvanic isolator is good. Now we are going to check in the other side. Once again, we are going to make the chart, and now we are going to connect the terminals of the multimeter in opposite way. Okay, right now we are going to start. Now, okay, 0.1, once again, is rising, 0.2, 0.3, okay, 0.4, 0.5, the voltage is rising, and 0.7, 8, and once again 0.9. In both sides is perfect. That galvanic isolator is working properly. In each pedestal you found 3 or 4 bus bars. For example, this particular bus bars is for three-phase outlet. Hotline 1, hotline 2, hotline 3, neutral and ground. In this particular case, I am going to do the example with double phase. I am going to check outlets like this with a hotline, neutral, and the ground on the side. Double phase. Okay, in this particular example, I have a phase number 1, the black one, phase number 2, the red one, coming from the transformer at the beginning of the pedestal. This is the power, 240 volts, 60 hertz, 100 amps. That power entered in the bus bars. Bus bar for hotline number 1, bus bar for hotline number 2, bus bar for neutral, and other bus bar for ground. The breaker is okay, you need to replace the outlet. That's the procedure. You need to go step by step. You start on the transformer at the beginning of the duct. After that, you check the bus bars. After that, you check the breaker, and after that, you check the outlet. Basically, the schematic. This is position A, position B, and this is copper and copper. Position A, position B, copper and copper. And internally, a piece of ferrous alloy, iron, is located in between A and B, but with those springs, that metal is separated. And this is the coil surrounding the metal, the ferrous alloy, the input. This is the output. In this moment is open. In this moment, if I check with the probe, I have power here. I have power here, the light is on, but I don't have power here. When I send the signal positive and negative, that the positive, right now I send the signal here, I have power on the signal, and of course I have power in the output, and of course the light is on. In this terminal and this terminal on top, in between this terminal and this terminal, the connection is normally open. When I don't have power in between 85 and 86, those terminals are open. When I power it, those terminals close and the light is on. In this moment, the switch is off. I don't have power. I don't have power in the coil. The connection between 30 and 87A is normally open. The light is off. When I power it immediately, the connection between 30 and 87A closed and the light is on. Okay. In this particular case, the capacitor is in between. The capacity in farad is in between 189 and 227 microfarads. In between 189 and 227. Okay. After I discharge the capacitor with a piece of wire in between those terminals, I can check. I select my multimeter in a capacitors. The voltmeter is off. Right now I go to this function. In this position there are two functions. The first one is for diodes and the yellow one is for capacitors. Okay, I need the second one. I go over there and now I press the yellow button and I have the capacitors. And after that, check the capacity in farads and verify if the capacity is according with the label. If the capacity is lower or superior than the range of the label, you need to replace the capacitor for other one exactly the same. Never less. A little more probably, but never less. I recommend replace the capacitor for other one with exactly the same characteristics.